Hi, everybody. Good to see you. My name is Dr. Ghazi. There was an article that was published in Nature, and Nature is the most prestigious scientific journal. In this experiment, what was published was that there was a particle that was the size of a virus, and that particle was shown to be both quantum and classical. When I first saw that article, I decided to make an explanation video about that experiment with some background about quantum physics and classical physics, and that video turned into something quite long. And I also wanted to talk about the philosophical implications of that experiment. Instead of putting it all in one video, I decided to make this video separately, and we'll do the science bit in other videos. If you're interested in the details of those experiments, you can subscribe and I'll post those later. Instead of completely skipping the science, I'll give you a brief synopsis so we can kind of have an educated discussion of what the viewpoint of the universe is in both the classical sense, the relativistic sense of physics from Einstein's relativity, and from quantum physics. The common thread that threads all of this together is the study of light. Newton thought that light was composed of corpuscles or particles, and in about 1704 he published the Optics, where he went into that. And that's what people thought light was made of. But there was another scientist by the name of Thomas Young who did this double slit experiment. And the point of the experiment was to see how does light behave if it goes through a barrier with two slits. Does the light propagate onwards as if it has these corpuscles and basically particles, in which case you would kind of expect two bands on the other side? Or does the light have a different nature? And what he found was that light propagated in a wave-like manner as it headed towards the detector, which is what you're seeing here. It looked like these two waves were interfering with each other, and what you got on the other side were these multiple bands. And that was the first experimental evidence that light had wave-like properties. In fact, it was thought that light is a wave. Then we have James Clerk Maxwell in about 1860s. He published his equations, which gave a deeper sense of the understanding of light. He actually wasn't directly working on light. He was working on electricity and magnetism. And we knew that a magnetic field, if it's moving, will generate an electric field. And we kind of use that when we have motors. That's why motors have magnets, or hydroelectric power plants. When we make something move and there's a magnet that moves, we get electricity. And the flip side was also known that a moving electric field has a magnetic flux that is generated. So both those things were known. He studied both of those equations, and the idea came to him that if you have a moving magnetic field leading to an electric field can lead to a magnetic field, both of these can lead to the other. And what's to stop that from propagating onwards? And he calculated the speed of what that propagation would be, and that speed matched exactly the speed of light, which is about 300,000 kilometers per second. Light can go around the Earth in a blink of an eye. And that was the first time we understood what the wave-like nature of light was, that it was actually an electromagnetic wave, which was self-propagating because of a sequence of magnetism leading to electricity in an ongoing wave, and the speed at which that causal event happened was actually the speed of light. The next breakthrough in the understanding of light came with Einstein. And Einstein took Maxwell's equations, which were suggesting that light's propagation is actually independent of anything that it's originating from. It has a fixed speed. In space, for example, light will always have the same speed regardless of if it's ejected out of a moving spaceship moving at half the speed of light. When that spaceship ejects light, it will still move at the speed of light, as it were for a person who's sitting still on the Earth. As you know, speed is related to distance and time, meters per second. But light's speed is always the same, but different people, if they're agreeing on the speed of light, they have to disagree on how much distance is covered and how much time is spent for the light to travel. It was a very bizarre realization. Because of that realization, we had to bend our understanding of space and time. I'll go into all of these things in detail in the videos that I've actually already made, but this is a synopsis. So essentially, Einstein completely changed space and time, but there was one commonality in physics, which was something called determinism. And determinism is the idea that there's a causal sequence of events, that A leads to B, leads to C, and in that causal sequence, the next step, D, is always going to be fixed. It's going to be determined by the antecedent A, B, and C causes that led to it. There is a physical cause for d. And this is a physical nature of life and the universe. When you propagate that onwards, you get the idea that everything is essentially determined. But a crack appeared in this deterministic view of the world, which started off also with Einstein, and also in the same year, in 1905, when Einstein published his relativity paper, he had also published a paper on the photoelectric effect. And in that paper, he described that light is composed not just of a wave, but of photons. He actually called them light quanta. So that was the first entity to be described physically as being indivisibly small as a quantum particle. And that was essentially the birth of quantum physics. And in quantum physics, bizarre results started to appear. So this was the break point from determinism into a different world. So what happened? What happened is that now that we knew that light is composed not just of a wave, but also of photons, we were able to eject one photon at a time, an indivisible quantum unit of light. And instead of a laser beam of continuous light waves, as we initially realized this was, we now know that it's not just a wave, we also have photons. And if we ejected photons one at a time at this detector, the most reasonable understanding would have to be that if you're ejecting one indivisible photon at a time, it has to go through one or the other hole and end up on the other detector at a location in one of the two bands where the photon may have passed through. But instead, what we found is that when you shot enough photons through, the pattern that you got in the detector actually was, again, a wave-like pattern. So somehow this photon was coming out as a particle, getting towards the double slit, and somehow interacting with itself, because the only way you get this wave-like band is if two waves intersect each other and their troughs and peaks intersect with each other, and you get an interference pattern, which has bands on the other side at the detector. And that band-like interference pattern is only created by waves. So somehow this particle of photons was turning into a wave, and somehow it was passing through essentially either both holes or neither hole. We didn't understand what was happening, but the result of the experiment was that the photon had a wave-like pattern. And not just that, if we decided to figure out how is the photon passing through, is it going through the hole over here or the hole over here, and you put a detector to figure this out, the moment you figure it out and you detect which hole the photon went through, that wave-like pattern disappeared, and the photon behaved like a particle again. Just the fact that you observed the photon and got information about which way it was traveling changed the nature of the photon and started having only two bands, exactly how you would expect if you were shooting bullets through these two holes and you would end up getting two bands on the detector. There was no explanation of this, but these were the experimental results that we had to contend with. The answer to how quantum physics explains these behaviors is that quantum particles follow what's called a Schrodinger's equation of a wave-like probability of existence. When a quantum particle is not detected, it exists not just as a particle, but as a wave of probabilities, of locations and states. It's called superposition, which means that the position of quantum particles is multiple positions, all in a wave-like pattern or of probabilities, not definite in what we typically consider as one particle. And through years and years of doing this sort of experiment to see what size of particle can still behave like both a particle and a wave, we started doing this with electrons, with molecules, atoms, and we found that all these particles, as our detectors got better and better, were also behaving in this wave-like pattern. And this article in Nature that was published in January of 2026 was the largest particle to ever have been shown to be both wave and particle-like. And it wasn't just a particle, it was a conglomeration of thousands of sodium atoms, the mass of which was the size of some biological entities like a virus or an antibody. So it brought quantum physics and the quantum indeterminism to a level that's so real that it's palpable, which is why I thought this would be an interesting topic to talk about, because both quantum physics and classical physics have very deep implications, and those are the things that I'd like to get into. So how can we use this in our own lives? Before we talk about the differences between quantum physics and relativity or classical physics, the thing that unites them is actually causality. That means A leads to B leads to C still exists. There was a variation of this double-slit experiment where causality itself was being brought into question, where events were seeming to influence prior events. But on further analysis of that quantum eraser experiment, that was actually not the case. Causality still was preserved. Causality is a bedrock of physics, in that even if we talk about the speed of light, where we talked about the magnetic flux and the electric field leading to one another, that is what causality is, that A is leading to B is leading to C. The speed of light is so fundamental to the universe because it actually is the speed at which causality happens and unfolds in the universe. Anything that has no mass unfolds at the speed, the maximum speed limit of causality, which happens to be also the speed of light or any electromagnetic massless radiation or wave. In Einstein's relativity, when we accept that the speed of light is constant, we recognize and realize that the simultaneity of events, of what I say is now and what somebody else who's at a faraway distance from me and is traveling, let's say, towards me or away from me says is now, is going to be different. People are going to slice through the time of now differently depending on their speed and direction. Let me introduce you to an idea called the cosmological block universe. The x-axis as you move forward is the axis of time, and the horizontal axis are slices of space. And as you move forward, you have a causal sequence from past to present, and it can be taken into the future. So normally if you're at rest, our now is going to be, like in this block universe, is going to be essentially that 90-degree angle from the time angle. So let's say we're stationary on Earth and there's an alien species in our now, far away in the universe somewhere else, who's going away from us. If their direction of motion is away from us, their now slice of what they think is now in the universe will not include us in the now as we think they are in the now. Their now slice will actually go into our past. The opposite can be true. If they come towards us, their now slice will veer into our future. And the only way simultaneity can be mobile like this is that if the sequence of events is definite. And that's because causality has to be maintained. So all understandings of physics agree that in events that have happened, if A leads to B leads to C, if that causal sequence has happened, there's no form of the universe where B leads to A, right? There's a retroactive causality. It doesn't work in that fashion. So we are fairly certain about that part. Where the two theories diverge is that in that causal sequence, in the moment of now, of the next event, when C is supposed to lead to D, under classical physics, under relativity, that D event is going to be determined based on physical pre-existing conditions of the universe. We have limitations that we may not be able to predict what D will be or what the next event in the causal chain will be. But if there was an entity that knew all the forces involved, they would be able to know for sure each event that would follow next. Fate and determinism have preordained the way things are going to go. The causal chain is cast. Events that are meant to happen will happen. In that perspective, free will is an illusion, just like space and time are an illusion. Then we have quantum physics, which is inherently probabilistic rather than deterministic, where we don't know for sure which of a multitude of possibilities will manifest itself out of a wave function of probabilities. Until that manifestation happens, quantum states are in superposition, where things are not well defined. Which outcome is actually going to happen essentially happens when the observation is made. For all practical purposes, that is our world line of now as to how things are unfolding in this moment. So where quantum physics differs from classical physics is that if A leads to B leads to C, if it will lead to D or D prime or D prime prime prime, or what of those probabilities will actually happen, nobody really can tell. It can't be that you know the mechanical forces of the universe as they are, and you for sure that D is going to happen. There is a fundamental probability where there's many different options of what could happen next. So this was where the two worldviews diverge. Where I would like to start is actually before that divergence, where quantum physics, classical physics, relativity all agree, which is in causality, that the causal chain that A leads to B leads to C, once it happens for sure, that B can never retroactively lead to A, and the events that happened essentially were meant to be. I feel like that's a good place to start because it answers a lot of questions that human beings struggle with. If we ignore causality, for one, we're ignoring the bedrock of what defines all of physics and all of science and everything that we understand or know based on experimentation. And it also defies logic, it also defies reasons where people sometimes need to understand the world in a way that they're not seeing it as. Let's start with an illustration of a hypothetical person. Let's say there's a girl or a child who's 12 years old and has had a very difficult life. And let's say this child is not acting very well. They could be doing drugs, or they could be getting into the wrong company. They could be doing actions that society would judge them for. Let's say you end up meeting such a person, and then you find out that they were born to an alcoholic family. Possibly there was abuse for the majority of this child's life. And let's say when you meet this child and you see how they're behaving, it will be somewhat obvious to most of us that their behaviors are to some extent, and maybe even for the most part, a manifestation and a reflection of their life, of the fact that they've had a difficult childhood, that they have a lot of trauma, that they have a lot of difficulties in life that prevents them from acting in a model citizen kind of way. And of course, you would expect that such a child would be disturbed. At that time, it's very easy for most of us to not blame the child and to understand that this is but a natural reaction to the life this child has lived, and nobody should live that kind of life. But let's say we move forward and this child is now 13, 14, 15. How would you think such a person is going to evolve? There's always chances and there's always a possibility that a person will turn their life around. But let's say you meet them when they're 18, the same person who you know has had a very difficult life, continued to get into trouble, and had friends and company that influenced them in a way that was negative. They got addicted to cocaine or some substance that also made them do other bad things. At 18, when let's say they're legally an adult, are we going to blame them for being a bad person, for making bad choices? Or are we still going to understand that there are some influences here that are causing these things? How about at 25? At what point does a person have the absolute free will to escape the consequences of their prior circumstances? At what point does a person escape their inherent inclinations? In some way, we are all a mix of our nature, which is something that we didn't choose to be born as, either aggressive, assertive, resilient, with some mental health problems. These are not choices that people always make. From one perspective, people are born different. And on top of that, there are the influences of nurture. And that essentially defines what will manifest in the next moment for this person. At what point does a person escape the causal chain of their inherent inclinations and the influences that they've experienced in life? Are the decisions that people make devoid of that history? Let's take another example of a person whose sister gets murdered, and you're in court and you see the murderer, who's a middle-aged man. He gets a life sentence. Even though the life sentence seems like a fair sentence, but you as a person might feel enraged that this is not justice because your sister is not alive anymore, whereas this person may live their life out in jail and still have associations and see the rest of his family. Let's say he has children, he's going to see his children for the rest of his life, even though he'll be in jail. But then it turns out that this person was actually a great father and was a responsible citizen. And something happened in the past 3 months and his behavior started changing. And he had become more violent and he ended up committing this murder. And then it turns out he ends up having a seizure while in jail and he has a tumor in his brain. And this tumor is life-threatening and he's going to die from it unless it's taken out. Does that change how you feel towards this person? Does it give you some thought about maybe allowing this person to, in fact, have an operation instead of giving him the death penalty, which you thought was the more appropriate option? Now, would you flip that all the way around and say, actually, maybe he should be allowed to have an operation so he doesn't die from his tumor, so that he can see his children grow up? Would you even say that maybe after the operation, if he goes back to being a kind, empathetic person, which he was before, and he meets you, would you even say maybe his sentence should be reduced? The point that this hypothetical is trying to draw out is that this tumor, in a way, is a physical manifestation of the life story of the girl that we talked about earlier, or a physical manifestation of the life story of many people, maybe all of us, that our pasts are not things that we chose. They somehow happened to us. Our inclinations were not things that we chose. We were born with them. And many people who may have wronged you or wronged others who may have done the wrong things, maybe we should keep that in mind, because what we're keeping in mind there is that the causal chain of actual events leads to consequences, that things don't emerge out of nowhere. So what we think of as a free will decision to kill someone or to steal or to take cocaine is not so free will as one might imagine. They're not devoid of the antecedent causes that led to those situations and those choices. And that's true for almost all of us, including people who you may feel are not acting appropriately as you would like in your own life. Maybe such thinking could allow you the magnanimity to have the grace to forgive them, or to at least have an understanding that sometimes people are the way they are for reasons that they themselves can't control. I'm not saying that there should not be justice. Of course, you have to punish and deter bad actions because, again, causal connections matter, and it matters that justice is served. But really the question is a little deeper, philosophical question of how you yourself feel about such events when other people are doing them or not acting in a way that is ideal. And not just for other people, but sometimes even for yourself, because you yourself may have things that you wish you did differently. If something could have happened, should have happened, I would have done this. If I had the chance, I would have done this or that. You are just as much influenced. If you can have the grace to understand the history of other people in this way, you should also extend that grace to yourself, that you yourself are just as much influenced by those antecedent factors. And it allows you the belief in this causal chain, which is the bedrock of physics, of science, allows you to see reality from a grander and deeper picture that takes into account all those factors that led to reality as it is now, to accept the past. Most things in life are out of our control, especially once they get into the past. So as you use this causal chains reality, which is true to both quantum physics, relativity, classical physics, and our lives, it also puts into perspective the fact that many of the gifts that most of us are born with, be it our health, be it our resilience, the fact that we can see, we can hear, we have these capacities to understand life, to understand the universe, where our lifespans are not 23, 30 years, where we have so many of these comforts that we didn't exactly earn. We didn't do anything when we were born to deserve the gifts that we have. They've been bestowed upon us. And it helps to keep that in perspective so that you can be grateful for the powers that have allowed for this past and for the present moment to exist. That cutting edge of the present moment, that's where quantum physics and classical physics diverge. Now the question becomes, in this present moment, are things deterministic? Who says that things are deterministic? Well, reason says that things are deterministic. Logic says that things are deterministic. Both relativity and classical physics are deeply rooted in determinism. The implication of that is that there should be no free will, because whatever choice that you make was factored in by the things that happened in the past, and you essentially have no choice but to make the choice that you're going to make, because all the forces that have led to this present moment will drive the next moment to be what it is meant to be, and nothing can change that. So some people may accept that conclusion as real, that free will is completely an illusion. But the problem there is that the thing that led them to that conclusion was rationality, reason, and logic, and science. But if they want to hold on to that, they really practically cannot keep holding on to that view, because from an evolutionary standpoint, a biological animal cannot experience life like that, because first of all, you never get food, you just be sitting at one place, and then your hunger would drive you. And then you may say, well, that's fine, just like an ant is driven to food, or an amoeba is going down a chemical incline, I will make decisions, but there was really no free will involved. Or they may say that I convince myself that there's free will and I act like there is. And that actually might be the logical thing to do, but it's the logical thing to do not because it's logically consistent, but because in order to maintain sanity, there is no other alternative. But one thing that such a rational person has to contend with and acquiesce to or give up is their claim that they're being fully rational. Because if you're being fully rational, you have to give up the claim of free will. The moment you accept that there is free will, or tell yourself that there is free will and that you are operating on that assumption, even though you base your worldview on rationality and science, your operational worldview of how you interact with the world and how you go about the world is based on a non-scientific and non-rational standpoint, if your scientific conclusion is that determinism is true. So it's logically inconsistent to live like that. Or if you do live like that, you have to at least say that, I'm just as logically inconsistent as somebody who may believe in something without actual physical evidence of something supernatural. Both parties are, to some extent, having to believe in something that allows them to live their life. The other problem is, let's say you just believe that you're faking free will and that you actually don't have free will. You run into a very big problem, which is that to have agency and to have motivation, you actually really need to believe that you have the freedom to change your own world. Because if you don't believe in agency, you won't have the motivation to change your lot in life. If you want to do good for other people and improve the world, you have to believe that you have the capacity and the will to do that. Because if you believe that nothing you do matters and everything is predetermined, you will lack agency. And a lack of agency is going to lead to a lack of success in the endeavors that you pursue. Otherwise, one, your chances of success are low, and two, the experience of the journey of getting something, of hoping for something, has no meaning. At the end of the day, your rationality and empiricism have to acquiesce to reality. You have, for practical reasons, for evolutionary reasons, for motivational and agency-related reasons, you have to live in the cognitive dissonance that your rational worldview cannot be fully self-consistent, because you have to believe that you have agency. So until quantum physics, I would say that classical physics, relativity, determinism, logic all led to this conclusion where people would have to lie to themselves. So is there an escape? Is there an alternative that is still scientifically accurate? And that's where quantum physics is an interesting opportunity. Before I say what quantum physics could help with, I should clarify what quantum physics is not saying. It's not saying that you have complete free will to do whatever you want. One, of course, for practical reasons, you're not going to be able to fly. There are limitations to your physical capacities. It's also not saying that you have complete free will as an agent to make all sorts of decisions completely irrespective and regardless of your prior causal influences. It's not saying that either. What it's saying is that in the deterministic worldview, where classical physics would say that causality mandates that the most physically likely next scenario that is going to follow the laws of physics will happen deterministically, quantum physics says that no, there is a fundamental chance and something else could happen. It opens up an opportunity. Because at the end of the day, all fundamental particles, and not just fundamental particles, but this nature experiment was talking about particles that are massive, are at heart quantum in nature. And therefore, the basis of reality is quantum uncertainty, quantum superposition, and a wave function of probabilities that branches or collapses in the sense that when something is manifest, when an interaction happens where information is gathered, which is essentially for practical purposes, the now moment happens and things become clear as to what is happening. Either there's a collapse in the wave function, or an alternative explanation in quantum physics is that the universe splits into the outcomes that were possible. In one way or the other, the outcome was probabilistic and not fatalistic. So it was not determined that the outcome had to be X. It could have been X, Y, Z, or a wave function of other probabilities of what that outcome could have been. What quantum physics gives us is that it breaks the causal chains of inevitability. There's some unknown interaction that happens between you and the universe that leads to some option manifesting itself. And that option has to manifest in the moment now. Now is the moment when the wave function of probabilities unravels into a manifest destiny that is not predetermined, that is not fated to happen, not in the past and not in the future, because once as we move into the future and it converts into the past, that also becomes part of fate. But this interaction is happening in the moment now. And that's where you can use quantum physics. You can use the causal chain of all of science, of all of physics, to understand the background of the past. And in the moment now, you can use quantum physics to move forward. And for the future, you don't control what happens. You don't control the outcomes. There is a fundamental probability to the outcomes. So that is not going to be in your control in any scenario. So you have to let that go as well. All you can control is the moment now. And that, I think, is the greatest learning, which I would recommend you take from quantum physics. Well, some would say that whatever I just described is actually not free will, because yes, maybe there's a fundamental chance to things happening, but that's not free will. That's not you choosing a particular outcome. My answer to that would be, however the choice is made, whether it's made independently by yourself, which is unreasonable in any scenario, or through an interaction with some unknown forces, the fact that there are options of choices being possible is an escape from a fully determined future where there was no other choice otherwise. However the choice ends up being made, it is still freedom from a future where there was never a choice at all. And the more interesting point, I think, is really even the question of what is free will? What is it that we value about free will? Is it that we have the choice to choose Starbucks coffee versus Dunkin' Donuts or tea? Is it the choice that we can choose the kind of shoe that we want? Is that what the level of free will is? These basic rudimentary choices? In that case, even your pets make choices of what they want to eat. Ants make choices of which way they want to go. Animals are making these choices all the time. Is that the level of free will that we really care about? Who really cares if it's you and your free will who makes the choice of coffee versus tea, or if it's the universe or determinism? It hardly matters as long as you're enjoying the tea, and if you're not, then you're going to stop drinking it anyway, and it really has no impact. So really, where we do care about free will is in deeper decisions, in decisions that really matter to our lives. In many of these decisions, because we live in a world where rationality and science and reason and being logical takes such precedence, many of us often think through our decisions rationally. We actually want to think in a logical fashion. And this is actually good depending on what that decision is about. So for example, if it's a complex decision about how to build a bridge, you actually want to follow logic. But logic and science are more in the realm of more or less determinism, because these decisions, if you make them purely on the basis of logic, you're essentially making decisions based on cause and effect related chains. There is no necessity for free will to make a better decision. In fact, it's better that you make the most logical decision, because that is the paradigm that you're using. But if you start giving credence to logic and rationality to make personal decisions about deep things that are important to you, then you don't need free will to make those deeper decisions. You just need higher computing power, because that will give you better logic. So that's probably not the right answer. In fact, what Einstein advised was that we should not use rationality and science and logic as ways of making decisions about our life or where to go. That would be like putting the cart before the horse. He felt that logic and rationality are tools, sort of like surgical scalpels, that you should use to an end that you have chosen to follow. And how do you decide which way to go? He believed it should be your imagination. So in Kantian terms, because he loved Immanuel Kant, he would say that though rationality is a crucial tool, it's a means to an end and not an end in of itself, or your guiding light. So where does free will come in at a deeper sense? Well, it goes back to the question of when do we use religion? When do we use spirituality? When do we use philosophical guidance? We don't use these deeper tools to decide if we want to have tea or coffee or which shoe to buy or to solve calculus problems. We use these sources of guidance to answer questions about what do we want to do with our lives? Do we need to do something different with our lives? Are we on the right track? Many times people, I would say, make the mistake of using logic and reason and rationality to answer these questions. And the problem is that there are logical, rational answers to these questions. And many people would say you should follow them. But I think one argument against that to some extent is that in that sense, everybody would make the rational, logical choice. There's really no free will in that either, because sometimes the rational choice is something that most people can agree on based on the circumstances of the world of what a person is best to do. But these choices are individual. And let's say it's not that generalizable and you make a rational choice suited to your best inclinations, suited to your personal circumstances, because you have an opportunity to take a particular job that makes sense. But there may be an inkling inside you which tells you maybe some other choice is better for you. Of course, in most things in life, it's always best to take the middle path, where you listen both to rationality, but also to your deeper voice. But really my question is, what is that deeper voice? And what is free will? Is free will making the rational choice, or is it something different? There is another voice inside of us, which is quiet, which gets drowned out by the noise of day-to-day life. It gets quelled by reason. It gets suppressed by rationality. You know, the Nature paper that was published where there was evidence of these large quantum particles acting like a wave, the way they figured it out was that on the detector, what they received was a wave-like fringe interference pattern. But that wave-like pattern was very difficult to see because there's so much noise. And the larger the particle is, the harder it is to see that wave pattern. So the scientists who published that paper talked about how difficult it was to see that signal and how happy they were when they finally ended up seeing that that was how the particles were interacting. But in order to get the signal, you had to remove all outside influences so that the true quantum nature of these particles could then be brought out. In the same sense, that voice inside of us is very, very easy to suppress. and we have to allow it to get out to the front so that its true nature can be expressed. One of the coolest quantum physics applications in real life is the leading theory of how many migratory birds orient themselves. And the theory is that in the eyes, in the retina of these migratory birds, they have a protein called cryptochrome. And when blue light hits their retina and this protein, it creates a pair of quantum entangled electrons whose spin is influenced by the Earth's magnetic field. And then changes in the magnetic field end up causing changes which are of a chemical nature in the retina through this mechanism. And that allows birds to geolocate and figure out which direction to head in. That explanation touched on some aspects of physics we didn't talk about, such as entanglement, where there's a pair of electrons or quantum particles that interacted with each other at some point in the past. And for eternity, they will be joint, where information on one will immediately lead to a change in the other. Essentially, quantum physics has physical influences in the strangest ways that we are only now beginning to even understand. So what is this voice inside of us? I haven't mentioned it, but yet you know the voice that I'm talking about. We don't have a name for it. Is it our intuition? Is it some neurons that have a quantum entangled pair somewhere else in the outside world, and that interaction influences how the current moment is manifest? Is it the joint influence of our ancestors driven into our limbic system and gives us a gut feeling of what is right or what we need to be heading towards or going away from? We don't know what it is. We can't name it. It seems like we almost have to quell the voice of logic to be able to hear it, to get a clear signal. Whatever it is, what we can say is quantum physics at least creates a wavefront of probabilities amongst which some interaction between something inside of you and something in the universe leads to a manifestation of a form of reality, which nobody can predict as to what that would be. That your past does not have to define your future. So how do you approach that moment where this superposition of possibilities manifests into one outcome? My recommendation would be to think of superposition, not so much in the pure physics superposition sense, but the word in a metaphorical sense, in two ways, because there's some interaction between you and the universe that leads to this collapse of the wave function or a divergence into a multiverse, or what's called the many worlds hypothesis. So one aspect of superposition, I would say, is something you should apply to yourself, that you consider yourself in a superposition. What that should imply is that when you meet the present moment, you act in a way that the best version of you would act. And on the flip side, believe in superposition in the universe, that there's some superpower that's in a position to help you. And then meet that moment with that belief. And then hope for the best, because the future is in nobody's control anyway. And whatever is best for you can happen. So thank you very much for watching this video till now. I really appreciate you spending the time. At least the work was put to some good use. On that note, if you did find it useful, please feel free to share it with other people. So to summarize, if we take things from a physics standpoint, we can use classical physics to explain everything that happens till this moment, to be grateful for what we have, to forgive those who have wronged us, to forgive ourselves, focus on the things you can do. Maybe life is not perfect, but many of the things that we do have are things that other people would have been very grateful for. And that could translate to being grateful to God or grateful to the universe for giving you what you have. So that's the use of causality. We talked about the problem with not believing in free will, is that it's practically impossible for an evolved creature like ourselves to not believe in agency. You have to give up logical consistency because you just can't live like that. Finally, what was the solution of how to use quantum physics? The way to exercise free will is you act essentially like superposition. Who is the best version of yourself? What would they decide? How would they interact? with reality now to create the future that they want. So you could use your religious outlook and try to be the best version of that. You could use evolution. In evolution, it's not the survival of the fittest in the sense of whoever is the most aggressive. That's not what survival of the fittest means for human beings. For human beings, it means the person who is the best human being, who can work with others, who can listen, who can lead, who can solve problems, who can be a role model to others, who other people want to be around. Where are the ways where you can be the best version of yourself and be that super person and believe, have hope that that version can come true? Because whatever was in the past, that path is known, that wave function is collapsed. You let it go, you accept it, you be grateful for it. But since the future is unknown, we don't know those path functions, we're in superposition. Think of the best possible outcome scenarios and hope that that will happen, believe that that will happen, and move forward. And then when the future comes to be and the wave function collapses, let go of it. Don't control the outcome. You cannot control the outcome. It becomes the past. And you keep moving forward, believing in yourself as the best version of yourself possible. One day you'll live up to that, and the world will conform, and the universe will conform to give you what you want and what you deserve. Thank you very much for listening. I look forward to seeing you next time. Thank you.